Today we are going to see the DC-DC converter design. Let's take one practical example. You have one microcontroller which needs 5 volt typical and current is around 600 milliamps. But you have 24 volt DC adapter. So in that case, how we are going to give supply to the microcontroller? So that's where DC-DC converter is used. If you see here, there is a three blocks in between our DC source and microcontroller. We are using DC-DC converter. So here this DC-DC converter going to step down the voltage and which is given to the microcontroller. For example, our case 5 volt is required and this 24 volt which is converted into, it's nothing but step down into 5 volt, and that 5 volt which is given to the microcontroller. For DC-DC converter design, there is some specific stages or steps we need to follow. Let's get started. If you take DC-DC converter design, so these are the steps we need to usually follow. First is requirement capturing, which is nothing but what is our requirement basically. What is my input and what is my output? That is what the requirement. After that, with this requirement, we are going to find the right part number for our DC-DC converter. Then we are going to analyze the spec by using datasheet. Following that, we need to do some design calculation for finding the inductor value and capacitor value. And then we need to design the PCB and procure the component. After we are procuring the component, we need to assemble the components into the PCB and finally testing. So in this tutorial, we are going to see till stage 5. Let's move on to first stage, that is requirement capturing. I just list down the input and output. This is input voltage is 24 volt. This is what we have, and these are the requirements for our microcontroller. So for this one, by using this requirement, we need to find the part number and based on the cost. So cost is also play the major role here. Okay, let's find the right part number for this particular spec. Go to the browser. You can choose DigiKey or Mouser Electronics. If you see the left corner, there is a products will be there. So under this, we need to choose integrated IC. So we are going to choose the power IC. So this is power management IC. We need to choose PMIC. Under this, select DC-DC switching regulators. Yes, this one. Okay, so this is the part number selection page. Here you can filter out as per your requirements. So I'm going to filter the manufacturer here because I'm familiar with Texas Instrument. So whatever you are familiar, you just filter out here itself. Now I'm going to choose TI. Yeah, here Texas Instrument. And my product status should be active. And wherever you are selecting like filtering out, right, the same way here also the result will be reduced. And function is nothing but it is stepping down, and output configuration is positive, and topology, if it is step down it is buck converter, and if it is you are stepping up means you need to choose boost. So for our case it should be buck converter. Okay, I'm going with adjustable as for now. Number of outputs 1, and here input voltage min and max. So I'm going to select max. Our input voltage is 24 volt, right? So we need to give some buffer. So in future, if we want to use the same converter for some other application, for that case I'm giving some buffer 20 to maximum 60 volt. Okay, and then I'm going to choose my current. Output current is around 600 milliamp. So as for now, I'm going for asynchronous rectifier. So it is no. Just apply all. So total 42 result. So under this also, my product it should be must stock and ROS compliant. Apply all. Then scroll down. You can find the part numbers. See here, IC regulator, buck converter, adjustable, and this is the current rating and the package type. Quantity available around 7,000 and price also around 78 rupees. And the basic specification of the product also you can find here. So what and all we have filtered out, same thing only you can see here below. And here you can see frequency. What is the switching frequency of the selected component? So here 770 kilohertz. Okay, everything will be available. Let's go and check quickly. Okay, if you see here, the above and below part numbers are same, but after 62, there is some difference in the letters. So here it is X and here it is Y. Let's check what is the difference. So here it is the page where you can to add the quart and quantity. You can see the price. If you are buying one quantity, what is the price? If you are going to buy 10, see the cost difference. So same way are you going to buy a tape or reel kind of thing. In the product attributes you can see the basic specification and here 3D model and all will be there. Here you can find the reach and ROS status. So let's open the datasheet here. Okay. Okay, let's check what is the difference between X and Y. So if you see here input voltage, okay, this is fine. 65 voltage is a transient. Okay, see if you see here, the X version switching frequency is 770 kilohertz and Y version switching frequency is 2.1 megahertz. Okay, we are going for X version. Then in that case, we are going to select this part number. This part number is selected, so we can paste it here. Okay, so the second stage also we have completed. Stage 3 specification analysis will see in the upcoming videos. Thank you.